Hello and welcome back to another coding session with Mr. Jacob. Today we want to further work a little on our pixel loop engine, and the last time we created this quite minimal sand falling simulator thingy here, which we will work on in the future. But today I want, as a preparation of optimizing that thing in order to make it even faster and better and do a lot more nice things, take a look at another topic that we encountered before. So let me quickly show you what I mean. We have our pixel loop engine here, and we are actually storing colors. So every pixel within our engine is simply a color, which more or less consists of 4 bytes, as we are on one hand using the pixels crate, which takes an array of bytes simply for the different colors, like always RGBA in this order as byte sequence for color. And we are storing them more or less in the same way. Our color struct is only some sort of wrapper to more easily create those colors and to manage those colors once we are kind of iterating or moving them around. The problem here is that we are actually leaving, I guess, quite some performance on the table. I'm not 100% sure, but I guess, because we are constantly converting between the color structure with its internal byte slice and the bigger byte slices, which consists of multiple colors, because there are a lot of situations where we are setting actually a bunch of colors. And I want to implement a feature now which allows us to blit certain amounts of the screen, so complete images, if you might say so, to another portion of another canvas, which we called that thing, so that we can simply copy data from one canvas to another. And our canvas interfaces always use color. But in the back end, they will most likely, even though we have only one interface at the moment, use those byte slices. Because usually you are representing image data in a linear array with maybe a stride. We might need to incorporate that, but so that there only is a linear array, and every times width you simply wrap during display into the next row. So what we want to do, and I said this before, is to use this color struct, or to actually create it in a more efficient way to be able to convert between slices of color and slices of U8. And I didn't know how to do this in Rust. I said before in other videos that I believe there must be some sort of possible way to do this, but I didn't know. So I read up a little on it, and I think I figured things out, and we will see. That's how far I have come. I found in std slice something called from raw parts, and what this actually can do is it can take any pointer to a const data t with a len and then convert that into a slice of this type t. So what we can actually throw in there is we can actually throw in there a pointer to our data and then convert it into another slice structure. This method is unsafe, so we will for the first time here use something unsafe. But I guess if we take into account that we need to make sure certain safety reasoning is done, it will be fine, because we are always converting between two well-defined data structures. So how this actually works is something like you have some sort of constant data pointer, and then you can simply make a slice out of that. And I guess we can use that with our color if we make something, if we make sure something actually is defined. So first of all, I guess we need to change our color definition. We change our color definition again back to something we more or less had before, but with a twist. what we are doing is we are splitting it again into U8 fields. So we are actually doing this RGBA, and then we should have actually this struct. We need to refactor our code in a second to accompany that, but I want to first talk about why we are doing that. Because I found out there is a neat little annotation we can do, which is repr C. And what repr C does is it makes this struct represented in memory as if it were a C structure. This is mainly there for compatibility with using C bytecode libraries, so C libraries, which we might want to link against in Rust. And this makes sure that this structure is treated as a C struct. Because Rust can actually, or is allowed to in its structures, to reorder the properties in memory if it thinks that in certain situations this might fit better for its runtime and performance behavior or optimizations. If we are doing this repr C, we are actually forbidding Rust to do that, so that the color struct will always be a struct with U8s in this order. And C structs don't have any overhead in memory. So that means that actually if we are creating it like this, it will be a simple byte slice of memory. So actually each color then will definitely be RGBA as bytes in memory in this order. So once we have done this, let's first of all refactor our color code again. So let's just walk through the errors. Yeah, we need to definitely create those here now. Yeah, I guess from bytes, I guess we will refactor that in the future, but let's quickly do something like sized bytes 0. Then let's copy that RGBA, and let's do 1, 2, 3. So this one we fixed. So what's with this one? This one's quite easy. We only need to do RGBA there to set that. And what's this? As bytes. How do we? Yeah, for now, I guess we will create something like self A, self B. Hey, but why? R, self. Come on. Self RG, self RGB, self A. And we will, of course, make this better in the future. Okay, this does not work. Why doesn't it work? Cannot return reference to temporary value. Returns a I see. So this is actually a problem. Maybe this is the first part where we need to really do what I wanted. Okay, maybe then let's start here, because I guess it is the last error. Yeah, it is the last error. So let's see. Let's return our color as byte slice. So I guess we can actually try and do that. Let's try and do that. Let's do something like byte slice, and that is, we need to wrap it in unsafe. And we want to do something like std slice. And now what was it called? It was called from raw parts. From raw parts. And we actually have a data reference here, because we should actually be able to do something like self as pointer or something like that. There was or did we need to let's see, self as, yeah, that's the method we are currently implementing, but there should actually be, let me see, there is a way to, or was it only on slices? Let me see, there was something like as pointer. Okay, so we can get a slice as a pointer. That actually makes sense, I guess. So our struct itself is not. What we actually need here is we need first let color we need this color as something, let's call it color slice. We need it as a slice, and I found something there as well. It was like you can convert a reference to one element into a reference to a slice with one element in it, because essentially that's from a memory perspective, that's more or less the same. So there was a function like from ref. Yeah, exactly. And from ref, it's not even an unsafe operation, is it converts something of type reference to t to a reference to a slice with t in it. And it does this without copying, which is quite nice. So actually, I guess we should be able to do something like std slice from, or what was it now called? From ref. And if we put self in there, I guess we should now have, let me quickly check the typing. Yeah, we should now have a slice with one color in it. And now we should actually be able to do this from raw parts thingy here by incorporating byte color slice. And now we can do as pointer because we want it as a pointer, and the len would be is there something like size off in size of Rust? Is there something? Let's see. Size off in std_mem. Okay, so that's actually quite nice. So I guess we should do then something like std_mem size of u8 times std_mem size of color. Oh yeah, then like this. And this would actually be the length, because this is the length of one u8, which, yeah, it's the size of one essentially. We might remove that. That's not needed. But we need the size of the color. So size of color should actually give us 4, because it's 4 bytes. So then we are converting this one into the correct format, I guess. So let's put that there, and now let's return byte slice, I guess. Okay, this does not work. Why does it work? Mismatched types. Found reference color. Wait, why are we getting... Oh, because we are putting a color slice in there. I guess we need to do something like as u8 as a const pointer to a u8 here. Still not working. So found reference u8. Okay, because we don't know actually the length. Yeah, but I guess we can change that. We can change that. So this should actually maybe work now. Yeah, this are just warnings. But yeah, we can remove those unnecessary parentheses there. So let's see if this actually still works. Okay, it seems we didn't break anything horribly. So I guess we are somewhat doing right. Another thing that is needed here, which I read, I guess it was in the Unsafe documentation. Where is it? Slice from, no, not from ref. From raw parts. There was something about alignment. Yeah. Data must be valid for reads. len mem size of t. Yeah, that many bytes. That makes sense. That we have actually done correctly. And it must be properly aligned. That means that the entire memory area, let me make this a little bigger for you. The entire memory area range of this slice must be contained within a single allocated object. Okay, we have that. Slices can never spawn across multiple allocated objects, no problem. Data must be non-null and aligned even for zero-length slices. One reason for this is that, and so on and so on. The problem is that we need to have it properly aligned. So if we are actually mapping this data to a U8, this is not a problem. But once we are starting to, wait, this is the wrong file. Once we are starting to map it the other way around, we need to be sure that the data we are mapping is actually aligned for the corresponding color, so that it is always aligned at 4 byte marks. And we need to take this into account and handle that correctly. But I guess this here should work now, and it should be a little faster and better than before, because we are essentially only using the already existing memory. We are not copying anything there, if I understand correctly now. So I guess we might do the same thing here, but in the other direction. So let's maybe do let's maybe do something like this, but in the other direction. Yeah, I guess this is still, I'm not sure if this is actually correct then, because we now might want to create that from a bigger byte slice. But I guess we need to check that the byte length, yeah, I guess we need to do something like, could use an assert, but I guess I will do something like bytes.len modulo 4 must be 0, or if it's not 0, then we simply panic. We say can't initialize colors or color slice from color slices can only be initialized with a multiple of 4 byte slices or something like that. Yeah, because we definitely need bytes that are a multiple of 4. Yeah, we need definitely in iteration of 4. And we need, we are returning, I guess now, a slice of self. So, so let's see. Can we do this conversion the other way around? So what I want here now is, I want, let's see, let color slice be unsafe. I guess we need to take the byte slice, the same thing we did below. So let's maybe copy that, because it's mostly the same. It will mostly be the same call, just with parameters the other way around. So what we are actually taking here is we are taking bytes as a pointer to color, and we are doing size. Yeah, we are actually doing bytes len divided by the size of color, and maybe we should use this here as well. So just to ensure, so just size of color, just to make sure that we are using the right size there. It is 4 bytes, but you never know. Maybe we change something in the future. Okay, so this should actually maybe even work already. So, but it's currently, this is, that's what I said about alignment. We need to check the alignment because this could actually fail, but let me see. So we are returning the color slice here. And I guess this looks okay. But now, before even doing that, we need to check that the given byte slice we have is correctly aligned. So it needs to be aligned to the size of color. So I guess we need to do something like, how do we check alignment actually? Rust get alignment type layout alignment. Yeah, I want to, a value can be checked with align of val, size of val, align of. Returns the ABI required minimum alignment of type in bytes. Every reference to a value of type T must be a multiple of this number. This is the alignment used for struct fields. Okay, this is, that's actually maybe what we, where was it? std mem align off. Okay, so what we actually want to do is we want to use bytes as pointer. And bytes as pointer modulo std mem align off, and then align of color, I guess. Must be 0. No, it's, if it's not 0, we are going to panic again. So panic alignment of color byte slice must be fitting for alignment of color struct. So we can actually not start anywhere in this slice, because then the byte alignments wouldn't match up. We always need a certain alignment for the color struct, which in this case we can even see that as if I'm hovering about it is properly there. So we need that. So it needs to be aligned. What's the problem here? Can I calculate a reminder of const? Yeah. But we should, can I do something like that? Okay, because I just want them kind of the memory address, and the pointer should be a usize. So no idea if this works. We will see. It's a little bit making me a little bit nervous. You might see that because I've actually never used unsafe code in Rust before, and I'm a little rusty, so to speak. And all this pointer arithmetic. In C, I wouldn't have that much pain doing that, but in Rust, I've never done it, and I don't know the Rust way to do it, if I simply can cast something like that. But I guess it's fine. So let's see. We still need to fix up the parts because I changed the way now this from bytes thingy here works. So maybe we should change the output type of our get function, because actually it should return a reference. It should not copy data. It should only return a reference, I guess. Yeah, I guess that makes sense. So if we fix that up, we of course need to fix that up here. Will we have other positions where we have the same problem? Set already gets color. Set range gets a reference as well. Yeah. Okay. So I think color from bytes, but color expected. Oh, yeah. I see. But is is there a reverse thing to do what we did before with this one element slice thingy? Size of from in std slice. So let's see. From ref. Is there something like can't I take a one element slice and make it Rust one element slice to ref so exactly the slice from a single element without what the hell is that? Yeah, accept all cookies. How to create a slice from a single element without copying that element. No, that's exactly what we saw there. So how to create a slice with a single element. Rust slice to ref. Is there something like that? From ref. No, I want to ref. Okay, maybe I'm thinking wrong here. So can't I just kind of take the element out of there? What does it happen if I do something like 0 here? Yeah, and then reference that, but will it copy it? Because I don't want to. I'm not 100% sure if this creates a copy. To do, check if this creates a copy. I guess it will. Wait, let me see. I guess we can simply remove the. Does our color have? Oh, our color has only clone. So essentially, it can't be So yeah, this does not create a copy. It seems. Because otherwise I would have to call clone specifically on it. Yeah, okay, so we are getting back a color. I'm not even sure I really want that. Maybe I want to return a slice here. Not sure. But for now, let's see. So actually now we don't have any errors there. So let's see. Okay, it still seems to work. That's good to know. Yeah, so maybe we should now think about our interface in general, because I think we should actually not have those get and set methods, at least not to be implemented by the interface itself. I think we should have something like set range and get range, because now we can do that efficiently. Maybe we should do something like that. Let me see, get range. So I want a range, and so this is actually kind of not right. I want to set a range to, we just did that before because we wanted to make things easier for us. So what I actually want to do is I want to do something like, I want to be able to give it a color slice, and it should then set that into the given range. And on the other side, I want to give it a range, and I want to get a slice of color here, I guess. Yeah. So I guess it should be like that. And I guess then these here should be somewhere here, and we should implement them within the trait for everything based on the set and get range. I guess that would make sense. So let's see. So get would do something like let color slice equal self get range, and I guess we need to calculate the index there. So let I equal y times self width plus x, and we are doing get range, and range is then from I to I plus 1, so we only want one slice there. And we should now return the color slice. And then we should be able to do what we did there before, color slice, 0. And it doesn't like that. Yeah, it doesn't like that because this is not a usize. So this should be able, we should be able to do that, and set should be more or less the same, but in the reverse order. So what we are going to do here is calculating the, and then we are doing set range, and we are giving it a slice of, so what we want to do here is this std slice from ref color. Yeah, that's actually quite neat. So where do we have this get implementations down here? We don't need that anymore. And set we don't need anymore as well, but now we need to implement get range. So let's put that at the right position, maybe above set range, and this would be, I guess, let's see. Oh, we need to change that as well. So let's do that in a second. Yeah, because now I guess we can do that in a more efficient way. Yeah. But let's see. Get range. Get range actually should be something like we are taking we need a byte range. We need a range into our byte slice now. So because the pixels create has this byte slice and not the color slice. So what we need to do is here something like I times range start times 4 to range end times 4. This is our byte range. And first of all, I guess we need to get the pixel buffer here. We don't need a readable version or a writable version of it, only a readable one. And then we actually want something like byte slice would be buff in the byte range. Yeah, and then we want to return something like color from bytes. And I guess we put our byte slice in there. Do we need a reference? Wait, what's its problem here? Oh, I think I need to do something like that. Yeah, okay. That was actually easy, and it should actually be done. We should be able to do that without copying data. And set range now is the equivalent in the other direction. I'm still not sure if the method name from bytes is because we are doing that on a color object. I would love to do that on something like color slice or something like that. Yeah, we will see. We will see. Okay, so let's just kind of remove that here, and let's see. We have the byte range, we have the mutable pixel buffer. So I guess what we want to do here now is we want to this time we need to copy color in, of course. But can we do, I should be able to do now something like buff byte range. What was it called? I had it before. Copy from slice. Yeah. Okay, let's see. Copy from slice, and now take the oh, we can't create a byte slice out of a color slice, an arbitrary sized color slice yet, can we? That's what we need there. So what did we implement actually before? We implemented from bytes, so we can create a slice from, yeah, that makes sense. We can output it as bytes. So what we can do actually is get one color as bytes. But what we can't do yet is we don't have a function which maps something like something like a slice of multiple colors to a slice of more than 4 U8s. There we go. So we need something like that. Okay, where do we actually implement that? So I guess we need something like a color slice of something. Can I do something like, that would be awesome if I could, but I don't think that I can. Can I do something like that? Cannot define inherent impl for primitive types. Consider using an extension trait instead. Wait. Do you want to tell me that I could do something like trait foo and then impl foo for... Wait, what? Could I do something like trait color to or 2 byte slice, and I could now do something like 2 byte slice, and I could do something like as, or let's call it as byte slice. Let's call it as color byte slice, and let's do, yeah, that's not color as byte slice. Let's call it the trait like that, and then implement that color as byte slice, and we tell here as bytes slice, and it's an FN, and it's taking a self, and it's returning a U8 slice, and can I actually now, okay, does this really work? Okay, let's see. So I guess essentially we want to do more or less the same than what we did here. So no, wait, we want the opposite. We want this one here. So yeah, actually we want this one here. So what we want to do is we want, no, wait. We now have, the color slice is our self. So we can put self in here. And we now need something like std size of color times self.len. So let's see. We are actually converting the slice with our colors, and we are taking a pointer to that, into a slice of U8s, and we are creating the length by the size of color times self length. Yeah. Okay. So actually this should give us color as byte slice. This should... Really? Does this work? Where were we? Where was I? I was somewhere down. Wait. Set range. There I was. So source, and it's not source. It's color, and maybe we should call it colors or pixels or something like that. I guess. Let's call it colors for now, and it's colors as byte slice. Okay. And now let's see, what have we changed here? What do we need to fix? Fill rect clear screen. Okay, let's go here. Clear screen. So now we are, oh, I see. We kind of duplicated the color, didn't we? Yeah, so that we can't do anymore now. So what we actually need to do here now is we either need to create a memory space where we pre-create these colors. Okay, that's actually not that nice, but it would in the end be the same as before. Maybe we can do this row-wise. The same thing we are doing it with with a filled rect. Maybe that's even more or less the same function actually. Okay, let's do the fill rect thingy first, because I guess we are more or less doing the same thing here. So we are doing filled rect row by row, and I guess that makes sense because those are always coherent memory areas that we can simply copy data into. So I guess what we want to do here is we want something like let row let's call it color row. And what we actually want to do is we want to have something like a vec here, which is color dot, no wait, how is it called? It's called color dot clone. Or can we actually just put the color in there and tell it that we want self dot width as usize? Okay, because it can clone it. I see, makes sense. Okay, now I'm not 100% sure that this thing we had before where I said it is not cloning it, like I guess here, to do check if clone happens. Here, I'm sorry, I'm not 100% sure that this isn't implicitly cloning. Let's remove that clone here and let's see if this now errors. Okay, it does not. So yeah, but maybe it's because we have a lot of other problems currently in our code. Let's check that again once we have fixed the other stuff here. So let's see. So filled rect. I'm actually implementing this by creating a color row in memory. That is something that we need to actually create. And then I could actually use that to set every row to color to a reference of color row, which should provide us with a slice. Okay, this does not work. Expected color found reference to vec color. Okay, can I do something like color row as slice? Okay. Expected reference color found reference. Okay. Okay, why is it oh, because I need to clone the color here explicitly, because otherwise it's just creating a vector of references of color. Yeah, okay. So yeah, this actually works. And then clear screen actually, yeah, we could, but it doesn't make sense. I guess it's more efficient to do it like that. Or at least it shouldn't be much of a difference. Maybe we will see. But I guess we can simply do something like self filled rect, and it's 0 0 self width self height color. Okay, where's the next problem? Get. Self get range. Wait, what's the problem here now? Cannot borrow self as mutable as it is behind yeah. Why should I need it wait, why has get I made a yeah, that's not right. I did that. That's unintentional, intentionally fucked up. We are not modifying data when we get them. So okay, so now we need to change something here. Yeah, I'm using actually this set range here to be not in need of converting the index back to xy. So I guess we now need, yeah, I guess now what we need here is this iter from ref again, and we just want a reference to empty color, and we, okay. Oh, it's not iter, slice. Yeah, and I guess we want to do the same thing here, std slice from ref. Okay. Okay, let's see. Okay, it's still working, but we are not, in all fairness, we are not in this implementation, we are not using fill rect or something. So let's maybe quickly patch that in here just to make sure that even though it's not needed, that we're doing that correctly. Where is our actually draw? Where's our draw function here? So let's maybe, after we rendered the grid, let's do something like canvas.clear screen to color from RGB, like whatever, red or something like that. 0, 0. And we actually need to reference that, I guess. Yeah. And then maybe we can do something like canvas, no, not clear screen, fill rect, and we are simply doing something like at 200, put something 100, 200 with color from RGB, whatever, 0, 2550 or something like that. No, where? There. Let's see. But it should work, actually, I hope. Or it does not. Source slice length does not match destination slice length. So I guess it's a good thing that we checked that. So librs229. librs229. So let's go there. It's actually our setRange command which does not work right. So what was the problem there? It said source slice length does not match destination slice length. So this one actually is a lot bigger than this one. Wait, why? So as it is 400, let's quickly check. It is 400, so I guess it is this here, because this one is 100 wide. So the clear screen worked. Okay. Oh, wait. Yeah, of course. We are getting all colors here. No. No, we are not. Wait, what? Are we using it wrong? Where is our... wait, this... Where is this actually called? Can't I... set range. Let's see. I think it is the filled rect thingy here. So maybe we are doing something wrong here. So I'm putting in the color row as slice, and the color row is actually self-width. It should be the size of the width. Oh, it should be, I'm putting in the self-width here. That's not right. I need the width of the rectangle to draw, which in case of the clear screen will be self-width. Okay, that makes sense. So let's see. Okay, I guess this works. Nice. So I guess we successfully refactored our color struct to be a lot less copy intensive, as to say. And maybe I want to rename this into from byte slice or something like that. To make it equal to this as byte slice thingy? I guess yes. I guess I want from byte slice here. Yeah. I like that better. Yeah. Okay, I guess we've done something right here, and maybe you have learned something together with me about using this typecasting stuff and unsafe code stuff. Yeah, and we wanted to check one thing. We wanted to check if this now breaks, and oh, wait. Color row and slice. This breaks? Okay, that makes sense because we can't clone this anymore. Let's just comment this out for now. So I guess then at this point there is no clone happening. So I guess Rust is intelligent enough to do that, right? To take then a reference to the more or less same thing. I hope so. I hope so. I will leave in the to-do there. Maybe we get another idea of how we could actually check that, or we could try to read documentation about that. But I guess that was a nice refactoring we did there, which actually in the long term should make things a lot faster and easier for us, because now we can copy colors around like we can copy copy byte arrays around. We don't always have this this conversion part there where we always copy it twice or thrice even. Yeah. And that here is something that I find quite interesting. But yeah, it kind of makes sense because you can add new traits to something like U8, for example, if you would want to. You can actually do that, and so I guess that is the same logic here. But I've never tried to do that on a slice type. That's actually interesting and good to know that it is possible. Yeah. Okay, I hope while I was trying to figure this out with you, you learned something as well. I definitely did, and I had fun doing it. And yeah, I hope to see you in the next time. So bye.